In today's video, we'll try to find out what's the maximum likelihood for the Bernoulli distribution. Let set D equal to x1, x2, x3 until x of n, and this is nothing but a set of observations. Now, the generic form of the likelihood function is P, that is the probability of D, where D is the set of observations, given mu is equal to pi, which ranges until n from 1, given the probability of x of n such that mu is given. Now the general form of the Bernoulli distribution is given probability, given an observation x for parameter mu is equal to mu of x into 1 minus mu raised to 1 minus x. If we generalize this to the likelihood equation, this is going to be probability of D given mu is going to be the multiplication of all terms until n, mu of x of n into 1 minus mu of 1 minus x of n. And this is the multiplication symbol. Now if we take the log on both sides, it's just simple for us to calculate, as well as if it's a log, it increases monotonically. So the log of P given distribution Z and mu is equal to the log of the entire multiplication term Now if we expand the multiplication term for a second, this is simply going to be log of mu x of 1 into 1 minus mu 1 minus x of 1 into log of mu x of 2 into 1 minus mu 1 minus x of 2, so on and so forth. If we break down these terms now, if we break down this term, this is going to be the log of mu x of 1 plus log of 1 minus mu 1 minus x of 1, right? And now if we generalize this for all the terms that are in the log, this is simply going to turn out to be log of mu x of 1 plus x of 2 plus x of 3 until x of n plus log of 1 minus mu n minus x of 1 minus x of 2 minus x of 3 minus until x of n, right? And now if we take the power rule of logs, this is going to imply x1 plus x2 plus x3 into log mu plus n minus x1 minus x2 minus x3 until x of n log of 1 minus mu, which simply implies now the summation of x of n into log mu plus n minus the summation x of n into log of 1 minus mu. Now, once we have established this, what we would ideally want to do is we would want to find the derivative of of both sides and assign the derivative of the probability for set D given mu is equal to 0. This is how we'll find the maxima. So we'll assign this as 0 to find maxima. All right. So now if we, the left hand side is ideally this of the equation that we just derived. This equation is going to be the right hand side. So we'll take the derivative of it with respect to mu. Therefore, for this term, the derivative is going to be with respect to mu summation x of n for all n. This is going to be constant because we are taking the derivative with respect to mu into derivative of log mu is going to be 1 by mu plus now the derivative of the other term is going to be n minus sigma x of n for all n. This is going to be treated as a constant, and again the log of 1 minus mu is going to be, if we apply the chain rule, 1 upon 1 minus mu into minus 1, because we are going to take the derivative of this with respect to the chain rule. Now we'll assign LHS is equal to 0. Therefore, the above equation becomes 1 upon mu for rearranging the terms, 1 upon mu summation of x of n for all x's is equal to 1 upon 1 minus mu into n minus summation of x of n. This is because of this minus sign. We can, if we take it to the other side of the equal to, this is what we get. Okay, and now if we expand this term, we'll have n upon 1 minus mu minus 1 upon 1 minus mu summation of x of n for all n. Now if we move the summation across n to one side, this is going to be the summation of x of n for all n into 1 upon mu plus 1 upon 1 minus mu is equal to n upon 1 minus mu. Therefore, summation of x of n across all n, if we cross multiply this, 1 minus mu plus mu upon mu into 1 minus mu is equal to n upon 1 minus mu. This and this gets cancelled, this and this gets cancelled. Therefore, the summation of x of n for all n, and if we take the mean, is going to be the mu. Therefore, the maximum likelihood for the Bernoulli distribution is going to be mu maximum likelihood is equal to the mean across all observations. The Bernoulli distribution is a set of observations, say x1, x2, x3 until x of n. But x1, x2, x3, these are nothing but a random set of observations or collections of ones and nulls. Therefore, therefore, the summation of x of n across all n's is simply the sum of all ones in the sample. Now say the sum of all ones in the sample is equal to m, then the maximum likelihood is going to be 1 upon n into the summation of x of n for n, and this is nothing but 1 upon n into m.